Okay, good morning class. So today we're going to look at the examples for exercise 2.6. Just check 2.6 quickly. I don't think there's a... Okay, so the exercise 2.6 basically deals with the combination of 2.4 and 2.5. Okay, so with that they are doing the exercise 2.6 odd numbers problem. Okay. So now we're looking at practical applications of finding maximum and minimum values. Okay. Practical application of finding maximum and minimum values. This is for exercise 2.6. 2.7, which is on page 30. Okay. However, this example is on page 30. Okay, so a practical application of finding maximum and minimum values. That's your reading for today. So now we're looking at the example. A farmer plans to construct a rectangular enclosure for his sheep using 100 meter of fencing. Okay. He makes use of an existing boundary wall. Okay. So now, if he's using an existing boundary wall, people is he going to put fence against the wall? Huh? You shouldn't. There's nothing wrong with his head, no? For you to put a fence against the wall is not going to make sense. Okay? He makes use of an existing boundary wall as one of the sides of the rectangular enclosure. Calculate the dimensions of the rectangle so that he can get a maximum enclosed area. Okay? You want the maximum enclosed area. So, with him needing 100 meters of fence, what does that mean? That means to say that length plus this length must add up to 100. Not so? So we know that the perimeter needed, or the length of the fence, which is 100, is going to make up of this length, which is what? X plus y plus, which is 2x plus y, which is equal to the perimeter, which is 100. So what do you notice now? Two unknowns, so simultaneous equation. Not so. But we know that we're going to make y the subject of the formula. Okay? So that we can have y in terms of x. That's the idea. You guys understand? Y in terms of x. So then y is equal to 100 minus 2x. That is equation 1. Okay? Or we can just say that's now the length of y. But what did they say? They said that calculate the dimensions. What are dimensions? Lengths.
Lisa Tanya
Calculate.
Martin, can you please report to the office?
That's you.
Lisa
Okay.
Tanya Martin.
Oh,
please
Martin.
report to the office.
Calculate dimensions. What are dimensions? Measurements or lengths or whatever of the rectangle so that you can get the maximum enclosed area. How do you calculate the area of a rectangle? Length times breadth. So what's the length here now in this case? Y, yes, which is also 100 minus 2x times the breadth, which is, you all see that, people? So how do I get rid of this? I multiply it. So you get negative 2x squared plus 100x. So what does this now do? Now what you see here is an algebraic expression for the area. Can you see that? The area of this triangle is now defined as negative 2x squared plus 100x. You all with me? So what I'm going to do is, what does this actually model? This models a quadratic function. What type of graph we draw for a quadratic function? Parabola. And because that is negative, the graph is going to have a maximum value. Can you see that? And hence, what are they asking you here? Maximum area. So what am I going to do here? Complete the square. I need to know the coordinates of this point. In other words. Okay. So what we do is, we take out negative 2 as a common factor. I'm going to complete the square now. No? Take negative 2 as a common factor, I get 2x squared minus 50x. Not so. Okay? So it's going to be, so I'm hearing somebody say 2x is a common factor. It is a common factor, but remember to complete the square. What do I need? I need a 1 in front of x squared. Understand why I'm only taking the negative 1? So what am I left with? X squared minus 50x plus a number to complete the square with minus the same number. And what number must be added to complete the square with here? Sorry? It's half times b, which is 25. Squared is 625. You all agree with that? Okay? So what is this now to us? Perfect square trinomial. It is negative 2 into, open brackets, it will give you x minus 25 squared minus 625. Now what? Multiply and get it into the brackets. So what do I have? Negative 2 into x minus 25 squared minus or plus 1250. Have you answered the question? No. So as you can see, this graph actually models a maximum. What were the coordinates of this being if this was a graph? 25 and 1250. So in other words, this has a maximum area of 1250 and occurs at an x value of 25. But remember, what did they want? The dimensions. Not so. You okay? They want the dimensions, so they want the x and the y. They want both. So to calculate the y, and I have to say, we have a y value of 100 minus 2 times 25. And what's 100 minus 50? 50. So we'll have a 50 meter by 25 meter to give you a maximum area. You understand, people? Any questions? So with that, you should be able to do exercise 2.7. We'll break that exercise up over 2 periods, okay? So you're going to start now with exercise 2.7, number 1, 2 and 3. Okay? And if you have a problem, we'll try and sort it out now, okay? The full lesson can be found in the description box below.